HVAC, more than comfort in hydrocarbon plants. You know me, I've seen my fair share of dirty jobs. From cleaning out clogged pipes to handling hazardous waste, I've been there and done that. But let me tell you, working around hydrocarbons is a whole other level of dirty. The residue, the fumes, the constant need for vigilance, it's a different ballgame. It's not just about the grime, it's about the danger. Every step you take, every move you make, you have to be aware of the risks. One spark in the wrong place and things can go south real fast. We're talking about potential explosions, fires and catastrophic failures. That's where HVAC comes in. It's not just a luxury, it's a necessity. Now you might think HVAC is all about keeping folks comfortable. Sure, in your home or office that's the primary goal, but in places like these it's about way more than that. It's about maintaining a safe working environment. We're talking about controlling temperature and humidity to prevent explosions. The right conditions can mean the difference between a safe day at work and a disaster. We're talking about keeping the air clean so workers can breathe. Inhaling toxic fumes can lead to long-term health issues. These systems, they ain't your grandma's window unit. They're designed to handle extreme conditions and keep everything running smoothly. We're talking heavy-duty, specialized equipment built for the toughest environments. These units are robust, reliable, and essential for safety. And trust me, when you're dealing with explosive gases, you don't want to cut corners. Every component, every system has to be top-notch. Bottom line, HVAC in a hydrocarbon plant is about keeping things safe, plain and simple. It's about ensuring that every worker goes home safe at the end of the day. It's about protecting lives, protecting the environment, and keeping those plants running smoothly. Without these systems, the risks would be too great to manage. So next time you think about HVAC, remember it's more than just comfort. In places like hydrocarbon plants, it's a lifeline. It's the unsung hero that keeps everything in check, ensuring safety and efficiency in one of the most challenging environments out there. Backups matter redundancy for non-stop operation. Let's talk about redundancy. In the world of industrial operations, redundancy isn't just a luxury, it's a necessity. Imagine your HVAC system goes down in a hydrocarbon plant. Not good, right? The consequences can be severe, affecting not just the machinery, but also the safety of the workers. Temperatures spike, air gets stale, and suddenly, you've got a recipe for disaster. High temperatures can lead to equipment failure, and stale air can create hazardous working conditions. That's why these systems are built with backups upon backups. Redundant systems ensure that there's always a safety net in place. Think of it like having a spare tire in your car, only way more important. Just as you wouldn't drive without a spare tire, you shouldn't run an industrial plant without redundant systems. We're talking duplicate fans, extra cooling units, the whole 9 yards. Every critical component has a backup ready to go. If one component fails, the backup kicks in automatically. This automatic activation ensures that there's no interruption in the system's operation. No downtime, no drama, just seamless operation. The transition is so smooth that you might not even notice when the backup system takes over. And believe me, when you're dealing with volatile substances, seamless is exactly what you want. Any interruption can lead to dangerous situations. Redundancy ain't cheap, but it's an investment in safety and peace of mind. The cost of implementing redundant systems is far outweighed by the benefits of preventing catastrophic failures. It's about making sure those plants can keep running, even when the unexpected happens. Contingency planning and redundancy are key to maintaining continuous operations and ensuring the safety of everyone involved. Dampers and detectors safety first in hazardous environments. Now, let's talk about two unsung heroes of hydrocarbon HVAC, dampers and gas detectors. These components might not be the most glamorous, but they play a crucial role in maintaining safety and efficiency in hazardous environments. Dampers, those are like big metal flaps in the ductwork. They might seem simple, but their function is vital. They control the flow of air, making sure it goes where it's supposed to, and nowhere it's not. This ensures that the air quality remains optimal and that any potential hazards are contained. Think of them like traffic cops for the ventilation system. They direct the airflow, ensuring that everything runs smoothly and efficiently. In an emergency, they can shut off airflow to isolate a leak or fire, preventing a bad situation from getting worse. This quick response can be the difference between a minor incident and a major disaster. Then there are the gas detectors. These devices are the silent guardians of the facility. These little guys are constantly sniffing the air on the lookout for even the slightest hint of a leak. They work tirelessly 24/7 to ensure that the environment remains safe. They're sensitive. I'm talking parts per million sensitive. This high level of sensitivity allows them to detect even the smallest traces of hazardous gases. And if they detect something's off, they sound the alarm, triggering shutdowns and alerting everyone to get to safety. This immediate alert system is crucial in preventing accidents and ensuring that everyone can evacuate in time. Fresh air in, hazards out, ventilation essentials. Ventilation is crucial in any workplace, but in a hydrocarbon plant, it's the name of the game. We need to constantly flush out those dangerous fumes and replace them with fresh, clean air. This means carefully designed intake vents strategically placed to draw in air from safe locations. We're talking away from potential leak points, away from exhaust vents. You get the picture. And speaking of exhaust, those systems are equally important. They need to be powerful enough to quickly remove any hazardous gases, venting them far away from the facility and anyone working nearby. It's all about creating a constant flow of air, pushing those hazards out and keeping the work environment safe for everyone inside. Section 5, Smart Control HVAC integration for seamless operation. We've got all these components, the dampers, the detectors, the fans, but they don't just run on their own. That's where the brains of the operation come in, the HVAC control system. This is like the central nervous system of the whole shebang. It monitors everything from temperature and humidity to air pressure and gas levels. And here's the cool part, it's all integrated with the building automation system, or BAS. So if a detector senses a problem, the control system automatically adjusts the ventilation, shuts off equipment, and alerts the folks in charge. It's all about automation and real-time adjustments, making sure the system is always running at peak performance and keeping everyone safe. Section 6, exhausting the risks, separate systems for safety. Now let's talk about exhaust systems. In a hydrocarbon plant, you can't just vent everything into one big pipe. You need separate systems for different hazards. You've got your regular exhaust for everyday ventilation, but then you've got dedicated systems for flammable gases, for toxic fumes, for anything that needs special handling. These systems are designed to prevent cross-contamination and ensure that hazardous materials are vented safely and effectively. It's all about keeping those risks contained and preventing a dangerous cocktail of gases from forming. Section 7, fighting corrosion, keeping HVAC systems alive longer. Here's the thing about hydrocarbon facilities. Corrosion is a constant enemy. Those gases, the humidity, the salty air if you're offshore, it all takes a toll on metal. That's why HVAC systems in these environments are built tough. We're talking corrosion-resistant coatings, stainless steel components, the works. Regular inspections and maintenance are key too. Catching rust early can be the difference between a minor repair and a major system overhaul. Remember, a well-maintained HVAC system is a safe HVAC system. Section 8, AHUs, the heart of hydrocarbon HVAC. The air handling unit, or AHU, is the workhorse of the HVAC system. Think of it like the lungs of the operation. It's responsible for drawing in air, filtering it, heating or cooling it, and then distributing it throughout the facility. In a hydrocarbon plant, AHUs are built to withstand the unique challenges of the environment. They're often housed in dedicated mechanical rooms, protected from the elements and potential hazards. Accessibility is key when it comes to AHUs. Regular maintenance is a must, so they're designed with easy-to-access panels and components for inspections and filter changes. A well-maintained AHU means clean, conditioned air flowing through the facility, creating a safe and comfortable work environment. Section 9, coils and heaters. Precise climate control in action. Let's dive into the nitty-gritty of temperature control. Inside those AHUs, you'll find cooling coils and heating elements working together to maintain the perfect climate. Cooling coils, typically filled with chilled water or refrigerant, cool the air as it passes through. This is crucial for removing excess heat generated by equipment and processes. On the flip side, heating elements, often electric or hot water coils, warm the air during colder months, preventing condensation and maintaining a comfortable temperature for workers. These components are built to strict standards, ensuring they can handle the demands of a hydrocarbon environment without compromising safety. Section 10. Airflow Management Balancing Act for Safety and Efficiency. Managing airflow is like conducting an orchestra, ensuring the right amount of air reaches the right places at the right time. Too little airflow and you risk stagnant air, potential hazards building up and an uncomfortable work environment. Too much and you're wasting energy and putting unnecessary strain on the system. That's where those dampers we talked about earlier come in, along with carefully calculated ductwork sizing and layout. It's a delicate balancing act, but when done right, it ensures optimal safety, efficiency, and comfort within the facility.